You are looking at the most automated factory ever built. No human hands will touch most of what is made here. Tesla is constructing a facility unlike anything on Earth. A $100 billion bet on robotaxis, built by robots. This is not a car factory. This is a machine that builds machines at scale. The numbers alone are hard to process. 5 million square feet rising from raw Texas ground. But the factory wasn't even the hardest part. Tesla broke ground on this facility in late 2024. The site sits adjacent to Giga Factory Texas, Giga Texas. That existing plant already produces 250,000 vehicles per year. This new structure will dwarf it completely. The target output, 2 million Cybercabs annually. That number requires a fundamentally different approach to manufacturing. Here's the crazy part. Traditional auto plants are built around human workers. Conveyor belts, assembly stations, ergonomic reach zones, all human-scaled. Tesla threw out that entire design philosophy. Every inch of this floor plan is optimized for robots. The facility will house over 10,000 Optimus humanoid robots, working alongside specialized industrial arms, around the clock. No shift changes, no breaks, no fatigue. 24 hours of production every single day. This is where it gets impossible. Before one bolt was placed, Tesla spent 18 months in simulation. Their in-house software modeled every production line in virtual space. The simulation ran at 10 times real-world speed. Engineers identified 47 critical bottlenecks before construction even started. That kind of pre-planning is rare in mega construction. Most factories discover problems after billions are already committed. Tesla discovered them in software and eliminated them first. But the simulation was only the beginning. The foundation work began in January 2025. Engineers drilled 2,200 concrete piles into the Texas limestone. Each pile reaches 30 meters below the surface. The combined load capacity, over 800,000 metric tons. Why so deep? The production lines run at extreme precision, sub-millimeter tolerances, and ground vibration is the enemy. The foundation was engineered to absorb and cancel vibration. Sensors embedded at 60-meter intervals monitor movement continuously. Watch what happens at the structural steel phase. Over 85,000 metric tons of structural steel were ordered, fabricated at mills in Pennsylvania, Texas, and Mexico. The steel arrived in a continuous convoy. For 6 months, at peak delivery, 48 trucks arrived on site per day. Each column in the main assembly hall stands 32 meters tall. The roof span, uninterrupted for 280 meters. No interior columns in the primary build zone. That open floor space is deliberate. Robot movement requires it. Overhead gantry cranes run on ceiling-mounted rails. 12 independent cranes operate simultaneously, never touching the floor. Then something incredible happened. During steel erection in mid-2025, a seismic micro-event occurred. A 2.3 magnitude tremor centered 4 kilometers from the site. The monitoring system flagged 17 foundation sensors within seconds. Engineers halted all crane operations within 3 minutes. 2 anchor bolts in grid section 7 showed micro-displacement, 0.4 millimeters, invisible to the human eye. But at Cybercab tolerances, 0.4 millimeters matters enormously. The entire section was resurveyed, re-anchored, and recertified. That delay cost Tesla 22 days on the critical path. What they discovered would force a partial redesign. The anchor bolt specification was upgraded across all remaining sections. 4,300 bolts replaced with a higher-grade alloy, site-wide. It added $11 million to foundation costs. It eliminated the risk for the remaining 40 years of operation. The next phase is where the real problem started. The Cybercab itself required a manufacturing revolution, not just a building. Traditional cars have 30,000 parts. The Cybercab has under 2,000. Tesla achieved this through Unboxed Process manufacturing. Instead of assembling a car sequentially, modules are built in parallel. The front subassembly, rear subassembly, and battery pack builds simultaneously. They merge in the final join in under 90 seconds. That final join requires millimeter-level alignment across all 3 modules. The robots performing this task are accurate to 0.08 millimeters. To reach that accuracy, the factory floor itself was laser-leveled, every square meter certified to within 1.5 millimeters of flat. Over 420,000 square meters of floor, laser-leveled individually. That job alone took 4 months and a team of 60. But here's what nobody saw coming. The Optimus robots required their own infrastructure, embedded in the building. Not power outlets, not Wi-Fi, something far more complex. Tesla installed a distributed compute mesh across the entire facility. Over 14,000 edge compute nodes mounted in the ceiling grid. Each node handles local AI inference for nearby robots. Latency under 2 milliseconds, critical for real-time coordination. The robots don't receive instructions from a central server. They process decisions locally, guided by the mesh overhead. This is a computing infrastructure inside a manufacturing infrastructure. Two buildings in one, built simultaneously, integrated completely. The cabling alone runs to 6,200 kilometers in total length, installed by a crew of 340 electricians over 11 months. Then the power systems changed everything. The factory draws 380 megawatts at peak production. That's more than the entire city of Waco, Texas, peak load. Tesla negotiated a direct high-voltage feed from ERCOT, a dedicated 345 kilovolt transmission line. Built specifically for this site, a transmission line runs 47 kilometers from the nearest substation. Construction of the line alone cost $290 million. On-site, Tesla installed a 200-megawatt battery buffer system, built from retired Megapack units, repurposed at scale. Grid fluctuations are isolated before they reach the factory floor. Robot calibration cannot tolerate power variation above 0.3%. The buffer guarantees clean power, even during Texas grid stress events. In 2021, Giga Texas lost power in the February freeze. This facility will not repeat that failure. Wait until you hear how the paint-free process works. Cybercabs have no painted body panels, zero. Every exterior surface is either exposed structural polymer or glass. That decision eliminated one of manufacturing's most toxic processes. Paint booths require solvent management, fire suppression, air handling, massive cost. Without paint, Tesla removed 180,000 square feet from the facility footprint and cut projected energy consumption by 11%. Factory-wide, the polymer body panels are molded in an adjacent building. That building connects via a climate-controlled enclosed bridge, 340 meters long. Panels arrive in sequence, matched to each vehicle's build order. Zero warehousing, zero handling delay. Direct line feed. That enclosed bridge operates at 22 degrees Celsius, year-round. Thermal stability prevents polymer expansion that would affect fit tolerances. This is what obsessive engineering looks like at scale. Then the robotics integration hit a wall. Optimus robots in testing achieved 94% task completion rates. The target for production was 99.7%, a massive gap. At 2 million vehicles per year, that gap means 12,000 failed assemblies. Every failure requires human intervention, breaking the automated model. Tesla engineers identified the failure mode: sensor drift under thermal load. The factory floor heats by up to 8 degrees Celsius during full operation. Robot joint sensors recalibrate at room temperature. At elevated temperature, positional error compounds, and the 94% appears. The fix required a firmware overhaul and a hardware retrofit. Thermal compensating sensor arrays were added to all 10,000 units. Deployment took 90 days. Completion rate in post-retrofit testing, 99.81%. Watch what the final assembly sequence actually looks like. The Cybercab moves through 18 joining stations. Total time from module merge to drive off, 11 minutes. 11 minutes. A human-assembled car takes 8 to 12 hours. That is the scale of the efficiency gap Tesla has engineered. At the end of the final station, a completed Cybercab sits. No driver needed. It drives itself to the outbound staging area. The vehicle's onboard AI is already active at Station 18. It navigates the 800-meter route to staging autonomously. 400 Cybercabs per day can exit through the outbound portal. At full ramp, that becomes 5,500 per day. 5,500 vehicles every day built by robots, driven out by themselves. The scale is difficult to hold in your mind at once, but the build itself still had one final obstacle. The roof installation revealed an unexpected problem. The 280-meter clear span roof required 48 custom fabricated trusses. Each truss weighs 340 metric tons. Lifting them required the largest crawler crane in North America. The Liebherr LTM 11-2000, capacity 1,1200 metric tons. It was transported to site in 54 truckloads and assembled on site. During truss number 31, a hydraulic failure occurred mid-lift. The truss hung at 28 meters for 6 hours while engineers resolved it. No injuries, no structural damage. But the incident triggered a full crane inspection and a 12-day halt. The remaining 17 trusses were lifted under a revised protocol. Two independent hydraulic systems, active simultaneously, never just one. Roof completion was achieved in March 2026, 11 months behind the original schedule, but the structure was intact. The next phase is where momentum returned. With the roof sealed, interior fit-out accelerated. 1,200 workers on-site daily for 60 days. Flooring systems, compute mesh, power distribution, robot mounting rails, all installed in parallel, managed through Tesla's own construction OS. That software tracked 4,200 individual work packages in real time. Schedule compliance averaged 96.3% across the final fit-out phase. By April 2026, the first production Cybercabs rolled from the line. Not prototypes, not test units, production vehicles. Serial number 00001, photographed, archived, and sent directly to a fleet operator. The factory was alive. Here's the crazy part about what comes next. This facility is Phase 1. Tesla has already filed permits for Phase 2, adjacent to this building. Phase 2 adds 2.8 million square feet. Target completion, 2028. Combined output at full Phase 2 capacity, 4 million Cybercabs annually. That is more than Toyota's global SUV production. From 2 buildings. The Robo-Taxi market Tesla is targeting is valued at $9 trillion, not billion, trillion. This factory is the infrastructure for a transportation system, not just a product. Every Cybercab that rolls out joins a software-managed autonomous fleet. Revenue per vehicle continues. Every mile, every fare, every ride. The factory doesn't just build a car, it builds a recurring revenue unit. At 4 million units per year, the fleet reaches critical mass. The network effects become self-reinforcing and nearly impossible to replicate. Right there. That is why this factory cost $100 billion. Not to build cars, to build a moat. No other automaker has the robotics, the AI, the energy infrastructure. No other company can build this building because they can't build what goes inside it. Look at the scale of what was achieved here. 5 million square feet, 10,000 robots, 11-minute assembly cycles, a roof span of 280 meters, cleared in a single lift, a computing mesh running 6,200 kilometers of cable, a transmission line built from nothing across 47 kilometers of Texas, all of it to produce a vehicle that drives itself out the door. They said full automation was a decade away. The first Cybercabs are already on the road. Subscribe to Built Impossible.